kind of alert them to be more focused about exercise and health issues. So why are we really concerned about that? It has been identified that physical inactivity is the fourth leading risk factor for global mortality. So it comes after high blood pressure, smoking, high blood glucose, diabetes, and then physical inactivity. And to continue the sad story, during COVID-19 pandemic, it was worse. So these data show the physical activity in Italian population. So we can see that before COVID-19, the physical activity is high, and during COVID-19, it's decreased. And these data can be extended literally to all countries and also for all durations. So, and we know already that exercise has a good impact for our health. And we have a lot of evidence that also exercise is good for brain health. And the story actually started from animal literature, using animal models to identify the effect of exercise on the brain function. Pretty basic level, if you put rats inside a cage, and we have two kinds of cage: standard cage, nothing but water and food, and enriched cage that they have something that can stimulate the behavior, the natural behavior, if they lived in the wild. So the studies indicated that the rats that have these enriched environment, they do much better in tasks that require learning and memory, such as Morris water-based tasks. In these tasks, the experimenter put the rats inside the pool. There is nothing there, only a platform here, and the rats at the beginning start to center around the edge of the pool, and then they figure out there is a platform over there. Then they go directly to stand there. Next step, they put something in the water to make it invisible, and then they increase the level of the water a little bit. So the rats that have this enriched environment, they go directly to the platform and they reach it. So in the right side here, we can see the distance by centimeters. So shorter distance means they don't need to swim a lot. They know where they are going. So the rats that the enriched environment, they go, they swim shorter distance, and the rats they have standard reach. Same research group, but with different direction here. We can see they focus on exercise, not enriched environment. So in these experiments, the experiment about a running wheel inside the cage, and it's a natural behavior for rats to go to the running wheel and they start to run. So it's a natural behavior for them. Sometimes I was, sometimes I was thinking it would be such a great if we had this natural behavior. When we see the treadmill, we go directly to the treadmill and we do exercise. It will be wonderful, right? So again, we can see the same evidence that the rats that have exercise wheel, they do much better in tasks that require learning and memory. So animal model give us a chance to go deeper and understand how it's going on inside the brain, how exercise can affect the brain function. And here we can see that this dots can show that this is a brand new neuron that link to exercise with the rats that have exercise. And here we can see also another study that shows control condition, enriched environment condition, and running condition. And we can see that number of neurons. So again, we can see larger number of neurons increase after the link to exercise. And this actually related to a lot of some molecular and cellular changes that happen inside the brain, like increase in optogenesis, in angiogenesis, and so on. So early studies in humans start to notice a nice relationship between academic performance and exercise. So this shows a nice relationship between fitness gram, which is a health-related physical fitness assessment. So higher score means that they have better fitness level, and fitness gram can be divided into several components like aerobic capacity, like muscle strength, like BMI. So yeah, so the more fitness level, the higher academic achievement. And the study divided the fitness graph into specific components. And here we can see the pacer test. So pacer test, it's a field aerobic test. It's 2 lines. The participants go from the first line and then go to the second line, and then they have a short time to rest, and then they go back again, and the time difference will be shorter and shorter again until they get tired. So simply laps is, so this is the number of laps that the participants go and back. So again, we can see that there is a nice relationship between the pacer laps and the academic achievement test. The study also examined the muscle strengths, like the flexibility and strength, and they didn't find a relationship with these specific components, but they found a same relationship with BMI, the body mass index. They have got the larger the body mass index, they have got the lower score in standardized achievement test in the math and reading. So here is a very simplified schematic of cognitive aging process. So what we can see here, this is exactly what happened to some people. So we want everybody to stay in this yellow line. You can see there is a little drop at the end, but this is not so bad. What we try to avoid is going down to this blue pass and of course to the red pass. So this is grab a lot of attention for researchers to know how we can do that. So some researchers go to the medication trials to find the medicine that can delay the onset of these abnormal cognitive changes. But unfortunately, it was not effective as the one that we wanted to be. So this is made the researchers give more attention to exercise or behavioral interventions. So when we talk about cognitive function, we need to think about it's an umbrella term that has some components. So cognitive function could be a very simple task, like the reaction time task. When you see the stimulus, you just push the button. This is very simple information processing. And also could be divided into executive functions, and also can be several aspects like inhibition, which is the ability to stay focused and to keep yourself away of distraction. The ability to hold information, which this is working memory, the ability to hold the information and manipulate in your mind. Cognitive flexibility, the ability to switch from task to another task and go and back between them. So as we mentioned earlier with animal literature, researchers start to find, to use some non-invasive techniques to know how exercise can influence brain function. So some works with humans, they use other techniques like MRI, like FNIR, that can show the differences between high fit and low fit. So you can think about it in cross-sectional study. You have a group of people, they have the same age, they have almost the same education level, they have almost the same income, but they are totally different in terms of physical activity and fitness. So the study here, in the left side, we can see a map of gray matter density, and the study showed that the part of the brain, like the superior prefrontal cortex, tend to be different in high fit relative to low fit. So high fit children, they have got a greater thinning effect than the low fit kids. And there is a study that shows that early absence in critical thinning is related to better cognitive performance. And on the other side, we can see that this study found that the high fit kids, they have greater integrity of white matter. So white matter is important, crucial for transmitting the information from different parts of the brain. So here we can see other neuroimaging studies have tried to compare fitness with differences in brain structure, with differences with cognition. And the study here utilized task and they monitor the size of the hippocampus. So as we mentioned, hippocampus is an important part of the brain that's responsible for learning and memory. So it's very clear here that we can see higher kids, they have that larger hippocampus than the lower kids. But more interesting here, the study conducted two memory tasks. The first one, that hippocampus independent task. This is to say that these kind of memories performed outside the hippocampus. The other task is hippocampus dependent task, which means that these kind of memories performed through hippocampus. So as we can see here, we found the effect or the differences between high pitch and low pitch on only tasks that rely on hippocampus. So this is a sound of like a more specific effect rather than it's a generalized. So this is another study, human, that focus on basal ganglia. So this part, and here we can see some slides of the brain that show different parts of basal ganglia. And basal ganglia is related to tasks that require executive functions. And again, the study found that there is difference between high fit and low fit in several parts of basal ganglia, like caudate nucleus, Whitman, and globus pallidus, but not in the nucleus accumbens. And this part of the basal ganglia is also apart from basal ganglia, but it's responsible for emotion and reward and effect, something like that. So again, you can see a kind of selective effect. Other neuroimaging techniques have been used a lot recently. This is called event-related potential, or ERP. This is to say that the participant can get an event. This event could be a sensory event, could be a visual event, and then we record the brain response for this specific event. So for example here, the participant got a sound, deep sound, and we can say that he got it more than 100 times, and then we got the brain response and average these 100 times, and then we can find a very nice curve like that. This is called ERP wave. And when we think about that, we can see some positive components like E300 and some negative components. And we believe that these components index several cognitive processes happen between stimulus evaluation and response production. So this is a study that examined the differences between high fit and low fit kids using Planck test. So in this test, the participant is instructed to respond based on the middle arrow. So if the middle arrow is pointing right, they click right. If the pointing arrow is like left pointing left, they click left. And of course, there's some surrounding arrows. This is a kind of distraction. So in this case, they're supposed to click right. This is left. This is left. This is right. So sometimes the middle arrow matches the surrounding arrows, and other times this matches the surrounding arrows. And the study showed that the high fit response more accurate than the low fit kids, and also a component called E3, it was larger in the high fit related to low fit. So that means that this component index a kind of a greater allocation of attentional resources given to the target stimulus. And this data suggests that maybe these differences in E3 may be responsible for the differences that was found in the behavioral data. So here we can see unpublished data from my lab, and we can see the current state of research in young adults. So the color here indicates the results that was found. For example, the red color means that there is no relationship was found in young adults. And the black means there is only behavioral data was reported, and the blue means only neural evidence was reported, and orange means that both behavioral and the neural evidence was reported. So from the first glance, we can see that there is a lot of red color, right? So this is a little bit questionable because this is arguing against the effect of exercise across lifespan. So we have a lot of evidence from younger generation, like kids, and we have also a lot of evidence from later generations, like elderly people, but in terms of young adults, we don't have that much strong evidence about that. So this is actually motivate us in Japan to do some experiment with young adults. So in this experiment, we focus on a kind of interference processing, and we compare between high-fit young adults and low-fit young adults. So we use a stroke task. Maybe some of you not familiar with this task. In this task, we ask the participant to respond based on either the word information or the color information. So in the color naming task, the participant have to respond based on the color information. So in this case, it's red, it's written red, but the color of the word is yellow. So the participant supposed to respond to the yellow color. And in the word meaning task, it's reverse true. In this case, we focus on the word meaning, not the color meaning. And sometimes the word and the color match each other, which is red, like that. This is a congruent or compatible condition. And in this case, like it's in green, but it's written red, this is the incongruent condition. And of course, the incongruent condition is more difficult and has interference than the congruent condition. One more thing here, it's a little bit not related to this word, but in general, in other studies, usually color meaning task has more interference than the word meaning task. So the question why, it's a little bit, has a lot of time to explain why, but the color information can distract the word information, not the opposite. But when we conduct this study with Japanese people, it was the opposite. We found that the word meaning task has more interference than the color meaning task. So this could be because of the language effect, because in Japanese they have two writing systems, hiragana and katakana and kanji. This could be the reason. But for now, I want you to think about that the word meaning task has more interference than the color meaning task. Also, the participants see a cue stimulus. This is like just a shape, it's presented for 1 second. This is a kind of to make the participant give more attention that the target stimulus will appear after 1 second. So the data showed that this is the reaction time, and this is the color meaning task, word meaning task, and this is the condition. So in general, we found that the more active respond faster than the less active young adults. And this is regardless of the stroke task or the stroke condition that show. And for the ERP data, we analyzed the cue-related potential or the brain response for the cue stimulus. So we found that there is no differences between more active and less active young adults. And the reason, and this data could suggest that the superior task performance that represented here is not related to CMD component, which is responsible for, or it can index motor preparation or readiness potential, but rather it's related to a kind of interference processing. And when we analyze the components that relate to the interference processing, we found a lot of differences between more active and less active young adults. So several components here like P2, E2, P3, and A450, we found differences between them. But these differences is not the same. So sometimes it depends on the task and also based on the condition. So to go deeper to this, we analyzed the P2 component. So we found that in general, P2 was larger and more active relative to less active young adults, regardless of the task and condition. And when we looked to the P3 component, we found that the P3 was larger only in the color meaning task, but not in the word meaning task in high active relative to the low active. And again, we found the E2 component was more negative in the high active relative to the low active in the only word meaning task, but not in the color meaning task. And we found also the A450 component, we found a condition effect, that the incongruent condition, they have larger A450, but this is only in the, with the more active group, but not in the less active group. So we can say that based on the task and the condition, the neural mechanism differs between high-fit and low-fit young adults. So obviously, correlation doesn't imply causation. So this is a limitation of cross-sectional study. We know, yeah, there is differences, but we cannot tell exactly this is because of exercise or not. So that's why we have a bunch of long-term interventional studies that focus on this kind of direction. So for example, in this study, kids randomized trial, this is from Illinois University in America, and the study recruited 221 children, and they divided them into intervention group and the witness group, and they have 9 months after school physical activity program. And we collect the data about the fitness and about the cognitive tasks pre and post the program, the physical activity program. So here we can see that, of course, the fitness improved after the exercise in the intervention group relative to the waitlist developed control group. And the study used also a modified flanker task. They instructed to respond based on the needle fish, right and left. And also they run another color shade switch task. So in this task, the kids instructed to respond either by focusing on the shape, this is circle or square, this is only one task, or also whether this is green or blue, this is also a single task. This is homogeneous condition task. The other condition that makes together these two tasks, so sometimes the kids have to focus on the shape, and sometimes they have to focus on the color. So this is the heterogeneous condition. So we can here see the change in response accuracy. So we can see that the accuracy improved only in the intervention group, and in the waitlist it's typical development because the program is 9 months. And again, with the color shade, the response accuracy improved. But what was more interesting here that the differences were found only in the condition that require more cognitive demand. So only in the incongruent flanker condition and heterogeneous condition, the effect of exercise or physical activity program can be shown. So here we can see the changes in the T3 component between the intervention group and the waitlist group. Yeah, it's very clear here, the differences. The same study here, but in this time they focus on the intervention group. So we can see the attendance rate of the kids, and here we can see the change in the T3 amplitude and the change in the response accuracy. So we can see that there is a kind of relationship over here. So the more you are attending the program, the more benefit you can gain from the exercise. And other work from Davis here has shown similar trend about this kind of dose-response relationship, but not in terms of attending the program, but about the amount of physical activity the participants were engaged. So here this is a control condition, and this is low amount of exercise, and this is high amount of exercise. And here we can see the executive function in the black, and the white is the mass achievement. So you can see here, the more amount of physical activity or exercise, the more gain you will have. So at this point, we need to distinguish between two different directions in this research area. The first one focuses on the chronic exercise or long-term or habitual effect of exercise. The other one is acute exercise. This is just a single dose. It sounds like a single dose of medication is taken. We go through also about the single dose of exercise. So we can think about the time, the intensity, the duration of this exercise can be a modulator variables. So in this study, we focus on the acute exercise effect. So we try to examine whether exercise, a single dose of exercise, has a general or selective effect on cognitive function. The reason for this question is that we have two hypotheses here. The first one that shows that exercise has a selective effect, or we can say that the executive functions that require more amount of cognitive demand can be affected by the exercise. And the other hypothesis is the general effect, that both just basic information processing and also executive function tasks can be also influenced or improved by exercise. So we recruited a group of young adults and we divided them into exercise group and control group. And then we have these 20 minutes of running on the bicycle, and the control group, they have 20 minutes just sitting rest. And we collect the data pre and post the exercise intervention. And then we run the flanker task, and this is your now quite familiar with this task. And we found, again, that the response time is becoming decreased or shorter response time in the exercise group related to the control group post-exercise with no differences in the exercise. And this is happening in the congruent condition that require basic information processing. There is no abstraction there, but again, also we can see the incongruent condition, we found the same effect. So it's a kind of general effect rather than selective in terms of acute exercise. And when we look to the ERP data, we also found a very nice differences. Of course, there's no differences in the pretest. That means that our methodology was good enough to conduct this study. And in the post-exercise, we found that the P2 was larger in the exercise group related to the control group. And also, we found some modification in the N2C and P3 components. So P2 is believed to index a kind of early stage of perceptual processing, and the A2C is believed to index a kind of classification, stimulus classification, and P3 related to the stimulus evaluation. So these results suggest that acute moderate intensity exercise has a general effect rather than selective effect. Another research direction that focused on open versus closed scale sport. And yesterday we had a session with, I don't remember the name, but she's a student in Klaus Lab, and she talked about walking football, right? And yeah, I think this is quite interesting because, you know, in these directions, we differentiate between the sport type, like closed scale sport and open scale sport. And in the open scale sport, this is kind of affected by the environment, included decision making, externally based. In the closed scale sport, like swimming and running, this is not affected by the environment. The scale is habitual and self-based. And the idea of the presentation about yesterday, they got the advantage of the we can open scale sports and the advantage of the closed scale sport and put it together. And this is quite interesting to get a kind of maybe promising effect, better than to have just one of them. So here we can see meta-analysis results of the study that try to compare the effect or the difference between open scale sport and closed scale sport. And here we can see in terms of the cross-sectional studies, it seems that open scale sport, they have maybe additional benefits from doing this kind of sport than closed scale sport. And this is focused on the inhibition and cognitive flexibility. And here we can see this is an intervention study, so you can notice the number is not that much enough to get a conclusion from this meta-analysis. So the study reported that there is no differences between open and closed scale sports. But in general, we have some evidence that the open scale sport may have additional benefits than closed scale sport. So in this study, we focused on, we tried to identify these differences between open and closed scale sport, and we recruited karate players, swimmers, and irregular exercisers, and we applied a very simple tag. This is auditory output task. This is the same one that I illustrated at the beginning of my presentation. When the participant gave the high pitch, he clicked the bottom, and there is a frequent not target stimulus here, and once when he gets the target, he pulls the bottom, something like that. And we recorded the EEG during this task, and we found that, in general, we found that the P3 amplitude was larger, and the P3 latency was shorter in exerciser relative to the irregular exerciser, and there is no differences between karate players and swimmer in this experiment. And yeah, this study suggests that both kinds of sports seem to have the same effect, but maybe it has some limitation because the number of participants was not that much, and we also focus on only two types of sports. Maybe if we can run more with other sport types, we can get a promising data. So in the conclusion of my presentation, we can say that fitness is related to differences in brain structure and function, and fitness has been linked to changes in cognition that are disproportionately larger for tasks requiring executive control and hippocampal dependent memory and learning. And also, single bouts of exercise improve cognition has a general rather than selective effect. And also, there is the number of studies increasing every day about these research directions that because we have now technology that we can detect, we can get more information about how exercise can influence the brain using other neuroimaging techniques. So we need to do further experiments and studies using these techniques. And also, we need to think about the synergetic effect. This is not only about exercise. We have other behavioral intervention we need to think about it, like mindfulness meditation, something like that. Maybe if we combine this kind of exercise and other behavioral intervention, maybe we can maximize the benefits of these behavioral intervention. And in general, we need to think to do more exercise as much as we can, and this will be very helpful for our brain health and cognition. And thank you so much for your attention.
Thank you very much for this enriching presentation. And I think it really stimulates a lot of inquiry from people. I think we'll open the floor for question.
I have a question about low fit and high fit kids. What the measure to make it high and low? What the measure to make it high? High fit kids.
Yeah, in terms of when we talk about fitness level, actually we do a kind of fitness test, like the Yamaka fitness test. We use this sometimes a maximum exercise test that we can differentiate between the kids based on the physical fitness. And when we talk about physical activity, we can use some simple things like the millimeter that can detect the number of steps that the participant do every day, and then we can put a rule that kids or participants who walk more than 10,000 steps, this is some rule that they can say that they are active enough. And who below that, maybe below 5,000 steps a day, it's seemingly less active. Yeah, thank you.
There's my appreciation for your presentation. First part of your presentation talking about social problems. But now I will ask you about one picture. You say that through your presentation, closed sports less than sports. Such as exactly what you mean exactly about it.
Yeah, I understand the question that why maybe open skill sport they have better benefits or maybe greater benefits. And this is, yeah, I think this is related to your study and your research about the social effect. Because when you do the open sport exercise, we involve with our mates on the team, with other teams. So this is maybe related to something like that. And as we see in the image environment with animal models, they have better performance in tasks that require learning and memory. So it could be related to the social effect or maybe the environment effect.
I want to ask you whether using the type of sport will have influence on cognition. Because some sport, let's say between resistance and endurance exercise, maybe some sport involve planning, like for example, swimming doesn't really use your brain mainly, but maybe other sports use your brain. Would this have an impact on cognition?
Yeah, this is a very interesting question. Focus on the type of exercise we perform. Yeah, this is, to be honest, I don't have a clear answer for you now. The reason is that most of the studies, they focus on aerobic exercise, not other exercise like weightlifting. And there's some studies that focus on this kind of exercise. But yeah, there is still some promising evidence that other exercise and weightlifting may have a good impact on the brain health and cognition. And this is the many further experiments about this. Yeah, thank you.
Last question.
Closed sport and open sport, according to which criteria? According to the climatic chain of the body during movement, or according to the environment surrounding?
Yeah, thank you for the question. This is based on the environment that we do the sport. So yeah, if it's just a circle where you repeat the same movement again and again and again, it's closed. But when you cannot predict when I play football, for example, I'm not sure whether I will pass, I will shoot. So this is the environment always a change. So based on this criteria, the studies focus on the differences between open and closed sport. Thank you.
Thank you very much. Maybe one more thing. Because usually sometimes say the benefit of sport on mortality also is related whether you do leisure sport or professional one. Because when you do professional, you're competing. Sometimes you do sport just only for leisure. With this, I think this is close to open and closed sport.
Yeah. When we talk about professionals and players, actually the data will be much different than when we talk about regular physical activity and people like us who just do exercise and we do physical activity in general. But yes, when we do a kind of professional, it has a specific effect when we talk about professional athletes.
Thank you very much. There's no question. Thank you, Dr. Ali.